We have two forces. One is of magnitude 24 newtons, that's F1. So this is 24 newtons. And the other one has a magnitude of x newtons. So I'll draw that here. And then we're told that the angle between them is 120, so that's given to us. We're told the resultant of the two forces is r, and that magnitude is 2x. So whenever we're finding the resultant of two forces, there's a couple of ways in which you can do it. One way, which is the easiest in this scenario, is to draw the forces from head to tail. So what I mean by that is, I'm going to start with F1. Though it doesn't matter what force you start with, you can start with either one. F1 goes towards the right, so I'm going to start here. This is my start point, I'll call it S. F1 goes in this direction, and then, so this is the head of that vector. We then have the tail of the other vector connecting to the head of this vector. The arrows should flow, so what I mean by that is the arrows should point in the same direction when going from the start all the way around to the finish. They shouldn't oppose each other. So there's your finish. This is F1, which is the 24 newtons. And the other one is the x Newton force, which is F2. So this is adding the vectors from head to tail. The arrows flow from the start to the finish. So we have an angle as well, which I haven't drawn on the diagram. That's 120, so that is what we have here. And that would mean that this angle here is 60 degrees. So once you've drawn the arrows from head to tail, the resultant connects the start to the finish. So that would be the resultant. And we're told the magnitude of that vector is 2x. So this would be 2x. And the question is then asking us to work out what x is equal to. So then we can use the cosine rule to work this out. We can consider that cos of 60 is equal to, okay, so let's label all these sides. So this would be A, and let's say these two are B and C. So cos 60 will then be equal to B squared plus C squared, B squared plus C squared, minus A squared, all over 2BC. 2B and then C. Let's simplify this. Cos 60 is a half. The right-hand side, so we have, this becomes minus 4x squared. So x squared minus 4x squared would be minus 3x squared. 24 squared is 576. So it'd be 576 minus 3x squared all over 48x. I'll bring the 48x up. I'll bring the 2 up to the right. So it becomes 48x is equal to, so 2 times 576 is 1152. 2 times minus 3x squared is minus 6x squared. And then bring everything to one side. So I'll bring it all to the left. We get this. Set it equal to 0. Solve the quadratic. And we end up with x being equal to minus 4 plus 4 root 13. Now there is another solution as well. The other solution is minus 4 minus 4 root 13. But that is a negative number. So that would give you, as a decimal, minus 18.4. We ignore the other solution. The other solution is negative, because that would imply that the force x is acting in the opposite direction. But the directions of our forces are not incorrect. We haven't assumed they're acting in this direction. We're told they're acting in those directions. So they shouldn't be incorrect, and therefore x should be positive. If x were negative, then that would mean that the force is actually, for instance here, going in this direction. So that's part A done. For part B, find the value of, or calculate the value of modulus of F2 minus F1, correct of 3 significant figures. So this is a bit different to what we had before. We had the resultant of F1 and F2, and that was equal to R. But now we have, instead of F1 plus F2, we have F2 minus F1. So that's a bit different. Again, we can draw these from head to tail. But before we do so, I'm going to rewrite this, or at least what's inside the modulus, as F2 plus brackets minus F1. So here we can see we're adding two vectors. We're adding F2 and we're adding minus F1. F2 points in this direction. If we think about the diagram that we have up here, this is F2 that points towards the top left. We know that the angle to the horizontal, at least in this direction, is 120 degrees. And then we're adding negative f1. So f1 points towards the right. Negative f1 would just simply point towards the left. So then if we're adding that vector on, instead of going towards the right, which is what f1 would do, negative f1 goes this way. Again, the arrows flow from start to finish, and the resultant connects the start to the finish. So this is the resultant that we're trying to work out. This was F2. F2 is x newtons. X is what we worked out down here. So that's minus 4 plus 4 root 13. I'm going to write that as a decimal. So 10.422. So that's what we have here. This is F2. And then F1. F1 was the force that was equal to 24 newtons. So let's have that up here. I'm keeping it as positive. We've taken into consideration the negative sign with the direction. By changing the direction, we have basically applied the minus sign. We don't need to then make the 24 negative as well. So there's our two forces. Then using the alternate angles rule, because these two lengths here and here are parallel, that would then mean that this angle here is 120. And then we can use the cosine rule to then work out what this unknown side is. So let's call that A. That's B, that's C. So then cosine rule, A squared is B squared plus C squared minus 2BC cos A. But we're trying to work out what A is, so I'm going to square root both sides, get rid of that square, and then simply square root the whole right hand side. So A is then equal to the square root of B squared, so the 10.4 squared plus C squared minus 2B C and then cos A. So cos of A would be cos of 120. Type this in, enter 3 sig figs. You end up getting 30.6.